Let's do one more example with Fisher projections. And this time I want to draw a compound, and you're going to recognize that we have seen this before. This molecule, notice that I'm going to draw two chiral centers. And this, making bolder. And I'm going to put another carboxylic acid group here. And I'm going to do OH, OH, H, H. We have talked about this type of compounds before. We have two chiral centers. This is one, that's another. However, this molecule is achiral. And we know this as a meso compound. We recognize it as having a planar symmetry, meaning we can think of a mirror here, bisecting the molecule, mirror this with that, and so on. So let's do the absolute configuration of these centers now. And let's say priority 1 of the chiral center above. Priority 2 is the chain here above. Remember that this carbon is bonded to, there's 3 bonds to oxygen. And then we have the priority 3 is below. And now what I'm doing is following priority 4, of course, is a hydrogen. It is on a wedge, so you're not viewing it that, say, correctly. So we're going to go now priority 1, 2, and 3. It looks like we're rotating counterclockwise, but since we're viewing it that incorrectly, then this will be R. That's the configuration of that center. Let's do the same with the other center below, and here you have priority 1, priority 2, 3 above, and 4 here. And again, we will do the same. We follow those priorities and remembering that convention. So we say 1, 2, and 3. Right. Oh, wait, I did it wrong here. No, I'm right. This is my priority, 1, 2, 3. So I'm viewing at that incorrectly. So it looks like cartwheel, but it's not. It's the opposite. It is S. Okay. Now I am going to draw the mirror image of this compound. So let's say that I have a mirror right here, and I'm going to draw what it will be the enantiomer. Let's see what happens. Now, I don't want that speck there. Two chiral centers, right? And I see here OH, OH, H, H on that side, the carboxylic acid, and the carboxylic acid. Now, let's look at that. So again, we recognize, of course, this is me, so that's the mirror image of that. But let's do the absolute configurations. Again, we have two chiral centers. Priority 1, 2, 3 is below, so you will go 1, 2, 3. But you're looking at that incorrectly, so it will be S. Now let's look at the other center. Priority 1, priority 2, priority 3 above. This is 4, so you will go 1, 2, 3. It looks like S, but you're looking at that incorrectly, so it is R. So notice the configuration of the two center is inverted. Now what if I do 100, like the manipulation that we explained in the previous video? Let's do 180 degree here. So what I want is then, in that rotation, I'm going to put this here in that rotation. So see what happens when you do that. Obviously, here you will have this group above. But then notice that you will have the OH here. So again, notice that this carbon here has the carboxylic group. Then we'll have OH and H. In doing so, again, 180, this went up, and now this went down. And you had here the hydrogen. So again, CO2H. I'm going to have this. and doing the rotation, 180. Check that out. What it looks like is identical to that. So that's what happens. So meso compound, the enantiomer to the meso compound is actually the same molecule. We did the 180-degree manipulation, which we know is just a different drawing. This molecule is identical to that, but it turns out that we see that it is identical to the first one. So in fact, these two molecules are the same. And that happens in the meso compound. And here, obviously, this is the same as the original drawing, so these are your configurations. So we recognize then that when we have a meso compound, then the enantiomer is actually the same molecule.